we're going to start looking at a function f of x equals sine of x over x. And we're going to start looking at what number does the graph approach for a given number. So this is something that we're going to call limit. We're going to kind of explain it graphically first. Then we'll write out the formal definition of it. And then we'll do some other videos showing some examples and some stuff from that. So graphically, if I said, what is the limit as x approaches 0 of our function up here, f of x, what I'm asking is, as you come along this function line here from the left, what number does it approach? And as you come along the function value here from the right, what value does it approach? We know there's an open circle here at 0, so we don't care about that for limits. We just want to say, as you approach from the left and as you approach from the right, what y value does your function approach? And in this example here, the function is approaching, just kidding, function's approaching 1. Because this y value 1 is where this graph hits. So if we said, what's the limit as x approaches pi of f of x? We'd say, all right, well, as you approach pi from above, you're approaching 0 from slightly above. Let's use a different color. So you're approaching 0 from slightly above. As we approach pi from below, we're approaching 0 from slightly below. We do take the value 0 out there, but basically the orange arrow here and the orange arrow here, they're both approaching 0. So basically what you do is you look at, if you have a graph, and you want to know what's the limit as your function approaches a number, you look along the graph and see what are the two, what's the y value that, as I trace along the graph approaches. Now this number doesn't always exist. We'll look at cases like that in a little bit, but this is the basic idea of a limit. Now a limit does have a definition, so we're going to write that out. So we'll say definition limit. And so we're going to say assume f of x is defined for all x. So assume f of x is defined for all x in an open interval containing c. So in an open interval containing c, but not necessarily at c itself. We say that, the limit of f of x as x approaches c is equal to L if the following things happen. If the absolute value of f of x minus L, this would be the distance between the function value and the limit, becomes arbitrarily small, so it becomes arbitrarily small when x is any number sufficiently close but not equal to the c. In this case, we write limit as x x approaches c of f of x equals L. So we could also say f of x approaches or converges to L I also say f of x approaches or converges to L as x approaches c. So what this is saying is if you let your x values get very close to the c, is there some number that as the x's get closer to the c, is there some number that the y values approach? So like back to our example here, as the x's get very close to 0, so as our x's get very close to 0 down here, our y values got very close to 1 based off of this function. So that's kind of what this is saying, is this definition basically says if as x approaches c, so as the distance between x and c gets very small, does the distance between the function values and L also become very small? And when that happens, we could say the limit as x approaches c of f of x equals L. So we'll pause there for a second.